Hi, this is Mukesh More. In this session, student will learn microprocessor architecture. So there are several components of the architecture. So first component is a data bus. Second component is a address bus. Then control bus, arithmetic logic unit. In short, you can say it is a ALU. Then we have register, then program counter, flags, and last component of architecture, that is timing and control section. So first component we will learn, that is system bus. So system bus having following components: data bus, address bus, control bus. So data bus is a bus. So bus is a medium to transfer the data, to transfer the address from one component to other component in microprocessor. So data bus itself says that it is used to transfer data from one port to other port. Microprocessor to the memory, data can be transferred, and microprocessor to input output device, data can be transferred. So the use of data bus is to transfer the data only from one part to the other part. Then second, we have address bus. So address bus is used to carry addresses of data of memory locations or input output devices. So address bus is used for carrying the addresses only of memory locations or input output devices. Now this address bus is unidirectional bus. So it is a one-way communication, and data bus is two-way communication bus. Similarly, after data bus and address bus, we have system bus called as a control bus. So this control bus is used for controlling the operations, and that operations are reading the data from memory. So to read the data from memory, it is one of the operation, and that can be controlled by control bus. Similarly, we have writing the data to the memory. This is again operation, that is the write operation to the memory. It can be controlled by control bus. Then we have interrupts. Interrupts may occur during execution of instructions, that are also controlled by the control bus. And we have direct memory access. So to access the memory in direct way, we have to use the control buses. So in this system bus, we have three buses: data bus, control bus, and address bus. And with these buses, we can say combinedly it is a system bus. Now we have, after system bus, we have arithmetical logic unit. So arithmetical logical unit, in short, you can call this is a ALU. Now this ALU is also called as a heart of microprocessor. This ALU is used to perform arithmetic operations such as addition, subtraction, etc. And this ALU is used for logical operations such as AND operation, OR operation, XOR operations. So all these operations are logical operations. So to perform arithmetic operations and logical operations, we have component called as a arithmetic logic unit. Then we have the next component, that is a register. So register is collection of flip-flops. So one flip-flop is used to store one bit data. Similarly, we have registers. It is a collection of flip-flops, and these registers are used for storing small data in the microprocessor. So it is not possible to store registers of microprocessor large data. So registers are divided into two categories, that are accessible registers and not accessible registers. So accessible registers are registers which can be accessed by instructions of microprocessor. So we have accessible registers like general purpose register, accumulator, and special registers like stack pointer. So we will take the first, that is a general purpose register and scratch pad register. It is also called as a scratch pad registers. That registers are accessible by instructions. Then we have second register, that is accumulator. This accumulator can be used by many instructions or many operations. Similarly, we have third register. That third register is a special registers. That register is stack pointer, and stack pointer register, short way you can say this is a SP register, and this SP stack pointer register is used for to keep the track of portion of the RAM. So this stack pointer is used for keeping the track of RAM portion. Now these three registers are accessible by the instructions. Now we have not accessible registers. So not accessible registers are instruction pointer, and this instruction pointer instruction register is not used by any other operation. So this instruction register is gets instruction from the main memory, and second, that is some temporary registers are there which are not accessible. Now after system bus, ALU and registers, program counter registers. In short, you can call this program counter as a PC, and this PC is used to keep track of address of next instruction. So PC holds address of next instruction. Now instruction to be fetched from main memory, this instruction having an address, and that address is stored with, or PC has the address of the instruction to be fetched. In multi-byte instructions, PC fetches the first byte of the instruction, and after executing the first byte, it will take the next byte of instruction. Then after program counter, we will have microprocessor flags, and these flags indicates certain conditions of the microprocessor, and this flag is of single bit, and this single bit register is used to store certain conditions which arises as a result of execution. Now, the first flag of flag register, that is a carry flag. Now, carry flag is used for if the carry is generated from MSB as a result of certain operation, then carry flag is set, otherwise it is reset. So, if the carry is generated from MSB bit of the result, then the carry flag is set, otherwise this flag is a reset. For example, in this example you can consider the first number is 1000 and second number is also 1000. Then we will do the binary addition of these two numbers, and this 1 of first number and 1 of second number is at position MSB, and if you do the addition of these two numbers at MSB, the carry is generated and carry is shifted to MSB plus 1 position. So, carry is generated from MSB position, then carry flag is set, otherwise it is a reset. Now, after the carry flag we will have 0 flag. If the result of operation is 0, then 0 flag is set, otherwise it is a reset. So, in this, if the operation result is 0, then 0 flag is set, otherwise it is a reset. Now, after 0 flag, we will have sign flag. So, sign flag is set when result of operation produces 1 as MSB. Result of operation produces 1 as MSB in the accumulator, then sign flag is set, otherwise it is a reset. Now, if MSB is a 0, the number is positive, and if the MSB is 1, the binary number is negative. So, in this way sign flag is used. If the result of operation produces 1 as MSB, then sign flag is set, otherwise it is a reset. Now, we will have parity flag. If the result of operation makes the parity of bits in the accumulator even, if the result of operation makes the parity of the bits in the accumulator is even, the parity flag is set, otherwise it is a reset. Now, after parity flag we will have auxiliary carry flag, and it is also called as a half carry flag. And if the operation produces carry from lower 4 bits, then this auxiliary carry flag is set, otherwise it is a reset. For example, we will have first number 0 0 1 0 1 0 0 0, and the second number 4 times 0 1 0 0. Now, when you look at these two numbers, we will have lower bits and higher bits. So, lower bits for the first number is 1 0 0, and higher bits for the first number is 0 0 1 0. Similarly, we will have 0 0 4 times 0 higher of the second, and 1,000 it is the higher of the second. Now if you do the addition of these two numbers, then the carry is generated from MSB of lower bit. So you can consider this is lower bit and this one is a carry. So the carry is generated from MSB of the lower bit. So this flag, auxiliary carry flag, will be set when the operation will generate the carry from MSB of lower bit to the next bit. Now after this auxiliary carry flag, we will have overflow flag. So overflow flag is used when the result of operation produces overflow, then overflow flag is set, otherwise it is a reset. So to occur this condition of the overflow, we will have example in subtraction is performed using 2's complement representation of the numbers. The overflow flag is set, otherwise it is a reset. Now after these flag registers or flags, we will have the last component of the microprocessor architecture, that is timing and control unit. So timing and control unit, this unit is used to generate proper timing and control signals which control and synchronize all the operations. So in short way, you can see we will have timing and control unit. This unit is used for controlling and synchronizing all the operations. So this is about microprocessor architecture components. So if you have any doubt, you can comment me, and thanks for watching my videos. Please share, like and subscribe my channel.